Again, one more time, just as a reminder, where you have chosen to sit is perfectly fine, so long as it does not cause problems with yourself being distracted or distracting other students. So you got to pay attention, you got to stay with me, and then I'm okay with you choosing your own seats. If devices become a distraction, devices are going to come up here in timeout, where you can make sure they are no longer misbehaving and no one else can touch it. If you're distracting other students, then I get to pick your seat for you. So make sure you're not distracting other people, make sure you're not distracting yourself. Other than that, we should be good. Does that sound reasonably fair? Okay, please be responsible with your choices. Number 1, what is x? Yes, ma'am.
It's 5.
It is 5. We can go through this algebraically. I can add 1 to both sides. I would get 3x equals 15. Divide both sides by 3. And I get that x is 5. The other way you could have gone about solving number 1, and the way you can check your work, is to substitute that value in the place for x and make sure that that gives you a true mathematical statement back. So in this case, we'd be wanting to know, does that actually equal 14? 3 times 5 gives me what? 15. So 15 minus 1. I get 14. On the other side, I had 14 all along. This is a true statement. So I know that that is the value that works. This particular example only had one solution. You're going to try to find the solutions in the set by substituting. So what I did over on the right, you got to make sure that you are finding all the values that satisfy. If you solve it algebraically, we get x equals and then just a single number. Number 2, what is x here? 3. X is 3. First thing I would do on this one is get my x's to the same side. So I would subtract 4x from both sides. I'd get 3 equals 3x minus 6. Then I would add 6 to both sides. So 9 equals 3x. And then I would divide both sides by 3. And so I get x equals 3. Just like before, I can also find that same answer by substituting in. I would need to put 3 in the place of every x I see, not just the first one. When we substitute back in, we're going to put that value everywhere we see that variable. And then I would simplify each of these. 4 times 3 would give me what? 12. And then I do 12 plus 3 and I get what? 15. So over on the left-hand side I have 15. Over on the right-hand side, the first thing I would do is multiply 7 and 3 together to get 21. And then I do 21 minus 6. What is 21 minus 6? 15. So I get 15 equals 15, which is true. Do you guys have any questions for me on the bell work? All right, we are going to be in your books. We're going to start off on page 75 today. We're going to talk about one more solving method that we didn't touch on yesterday. Yesterday we solved an equation. We wrote an equation from a story problem and solved it. And we solved for a variable. What I want to look at today is using a graph to solve. We can use a graph to help us solve. Page 75, yes. And somewhere in the margin on page 75, I need you guys to get this written down. You've got all this text up at the top of page 75, but there's a really big key concept that's buried in all of these sentences. And I want to make sure that we highlight that and that we pull that out. The solutions of an equation sometimes get called a different name. They get called roots. So in the margin, I want you to write down that solution equals root. I can use those two words interchangeably. I can say solve this equation, or I can say find the roots. Same exact question. We solve the equation for 0 and then replace 0 with f of x. These solutions also get called zeros because of that. So again, in the margin, I want you to have this written down. Solutions mean the exact same thing as root, means the exact same thing as a zero of the function. I'm going to make these plural because this is true when there's one or more. So this is my solutions. Same thing as roots. Same thing as zeros. I want you to look at this graph. When I'm trying to find the solutions, the roots, the zeros from a graph, what I'm looking for, what I'm looking at, is the x-intercepts. These 4 ideas all mean the exact same thing. My x-intercepts, which are the same as my roots, same thing as my solution, same thing as my zero. And it's the x part of the ordered pair that would be my solution. So when I use a graph to help me estimate the solution, I want to find where it's crossing the x-axis, and I want just the x part of that ordered pair. Please make sure that you have these 4 words written down. We're going to talk about these all semester long, and I will use them interchangeably. I would be expecting a bell work before the end of the week where I just ask you to write down the synonyms for solution. Please make sure you have this written down. These 4 terms, you have to know that these all get used interchangeably in questions. And I'm asking the same question no matter which word I use. So far, so good? Yeah. All right. So we're going to do this with a graph. If I want to solve something by graphing, first thing I need to do with it is to graph it, right? If I'm going to solve it by graphing, the first thing I need to do is graph it. Let's go look at example number 5. We're going to be on page 76 now, so go ahead and turn the page. We're skipping number 4. I want to go to number 5. First thing I need to do, if I'm going to solve by graphing, is to graph that function. Here is the function that they gave me. So I'm going to write that down over here so I can see it. C equals 1,576 minus 165 m. What does m mean? Yeah, what does m mean? Minutes. It says m minutes right here. So m means the number of minutes. What does c mean? Climb. What about climbing? Number of, yes, the number of steps that they have left to climb. So they used C for the number of steps remaining. Why they didn't use S, I'm going to go with possibly because my S's can sometimes look like 5s. So I try to stay away from letters that also look like numbers when I'm being messy. C doesn't look like any numbers if I write it clearly, right? So that's why I think that's why they chose C. You could have used S here if you want. You just have to be very careful if you're going to choose things other than X and Y. They've gone ahead and graphed this for us already. I want to make sure that we understand this graph and where these pieces are coming from, so that if I ask you to solve by graphing, you can make the graph first, and then we can use that to solve. When I look at their equation right here, it reminds me a lot of slope-intercept form. What are the two variables we use in slope-intercept form? It's y and what? What are my variables? Things that stay letters.
I thought you said letters.
Nope. My variables are x and y. What are the variables that they used here? They didn't use x and y. They used c and m. So this is what they're using instead of y. They're using a c. But where's m? It's not right after, like mx is not right after the equal sign. When I look at their equation, where's the number that has a variable left with it? At the end. This is this part right here. So when I'm looking at the way they wrote their equation, which part is my slope and which part is my y-intercept? Yes. The y-intercept, when they have something written in slope-intercept form or it looks very similar to slope-intercept form, your y-intercept is always going to be the number that does not have a variable with it. So here's my y-intercept. The number that has a variable with it is our slope. This part right here. When I go look at the graph, where's the y-intercept on the graph? Yeah, almost at 1600. If you look very closely, the line starts just below that. So here's our y-intercept. What's the slope again? Super close. Negative 165. Notice our slope is negative. And so my graph, my line, goes down. When I look at this from left to right, if I have a negative slope, my line is going down. You guys okay with how they graph this now? We want to use this graph to try to estimate the zero. We want to estimate this root. So that's the second piece we're doing here. Give me a synonym for zero. Roots. Solutions. What else? There's one more, and it's the key to answering this one. Intercept, specifically my x-intercept. Zeros mean the exact same thing as root or solution or x-intercept. So if I wanted to use this graph to help me estimate the solution, where should I look? Where should I look on the graph? We're going to look at the line, and I want to see where it's crossing what? The x-axis, yes. So down at the bottom, this is my x-axis. So right here is where I'm looking. This is my x-intercept. And so that is my solution, my root, my zero. Looking at the graph, is that right at 9? Is it touching right at the number 9? Does it go all the way to 10? Does it go all the way out to 10 on the x-axis? Looks like it's in between the 9 and the 10, right? Estimate that for me, ballpark. If it's in between 9 and 10, with the way this looks here, you would guess it to be about what? 9.5, 9.5. So looking at that graph, it intersects the x-axis at about 9.5.
It looked like more of a 9.7 to me.
9.5, 9. If you're estimating on the graph, I'm fine with whichever estimate you come up with. It needs to make sense with what I see. But yeah, I wouldn't count 9.7 as wrong. This means, so if we estimate it at 9.5, this means that Paul finished the race in about 9.5 minutes. Do we normally say 9.5 minutes if we're talking about 9.5 minutes, or 9 minutes and how many seconds? 30 seconds. Tell me how you got 30 seconds from 9.5. Half a minute is 30. Well, how much is a whole minute?
60 seconds.
60 seconds. Okay. I want to talk about this off to the side before we go and we actually solve this out precisely. If I have 0.5 of a minute, you said half a minute is 30 seconds because how many seconds in a whole minute?
60.
So 60 seconds is the same thing as 1 minute. Look at what I wrote in black there down at the bottom. 60 seconds on top of my fraction, 1 minute on the bottom. Do you guys agree that the top and the bottom of that fraction are showing me the same amount of time?
Mm-hmm.
I'm just measuring them with two different units. I can take a fraction like this that's showing me the same amount of time just with two different units of measurement. And I can use this to convert that decimal into a number of seconds. I can take any number and turn it into a fraction by putting it over what?
1.
Over 1. When I have units that are the same between the top and the bottom, they will cancel each other out. So minutes will cancel with minutes. How do we multiply fractions together? Straight across. So I'm going to do 0.5 times 60 on the top and 1 times 1 on the bottom. What's 1 times 1? 1. So I have 0.5 times 60, and then I still have seconds there. Now I could grab my calculator and multiply those together.
Wait, ain't it 500?
Nope, that would be 30 seconds.
Oh.
Grab your calculator and do it for me real quick. 0.5 times 60.
I got it. Get started.
Double check. I want everybody to verify. 0.5 times 60.
30. See, I did that in my head too. 25 times 60.
Oh, 0.5? I thought you said
It's
5.
30, right?
No, 0.5 times 60 is 30, yes.
5 times 60 is
I did it in my head too.
5 times 60 is 300.
I did it in my head.
No, you didn't.
Oh,
I just
God.
seen her
All right. I want to understand why we stopped to do this.
Bro, I said
Because in just a moment, we're going to go through and we're going to solve this. Instead of using the graph to estimate, we're going to see how close our estimate was to reality. And we're going to write that decimal portion as a number of seconds. So we need to make sure that we can use this conversion. All right. So from the graph, it looks like about 9.5 minutes. I want to use this equation to solve algebraically. We're going to find the precise answer to this. First thing I need to do, it says substitute 0 for C. So that means where I see the letter C, I'm going to replace it with a 0. So far, so good? Guys, please make sure phones stay put away. First thing we do is substitute 0 in the place of C. Because when we're talking about an x-intercept, what do I always know about that ordered pair? The y part is always going to be 0. I don't necessarily know what the x part is, but the y part is always 0. So if I'm trying to find my solution, my x-intercept, I can take 0 and put it in the place of y, or the variable that they are using for y. I need to use order of operations. We talked about this yesterday. I need to use PEMDAS since we are solving, isolating something. We go backwards when we are solving, which means I'm going to start with which operations? Adding and subtracting. Do you see any plus or minus signs over where m is? Yep. Here's m. I see a minus 165, but that's smashed right next to m. And I can't move m. That's the thing I'm trying to get alone. So if I can't get rid of this part, what can I get rid of? The other part, that 1576. Is 1576 positive or negative? Positive. How can I make it cancel then? Subtract it. So minus 1576, if you do it to one side, got to do it to the other side. Minus 1576. That's going to cancel here. So I'm going to have negative 1576 is equal to what? What do I have left on the right-hand side?
Negative 165.
Negative 165 m. What is it that I want to get alone again? M. Well, here's the piece I want to get alone. How do I get rid of that negative 165 then?
Adding to itself. Oh, see, she didn't give me a chance to correct myself.
We're going to divide. Why are we dividing? Yes, whenever I see a number and a variable smashed next to each other and I don't see an operation in between them, that is multiplying. And so I have to use division to undo that. All right. Grab your calculators for me. Cell phone calculator is fine. Negative 1576 divided by negative 165. If you need to borrow a yellow calculator, you're more than welcome to. They're right here. You can do this on your cell phone calculator also. Negative 1576 divided by negative 165. Negative 1576, negative 1576, divided by negative 165. If you can do that in your head, you are better than me.
Negative 1,741.
Nope. We're not subtracting. We're dividing. Yes. 9.55. Why is my answer not negative? That's absolutely correct. A negative divided by a negative is going to give me a positive. So we get a positive 9.55 for m. So the solution is about 9.55 minutes. That's how fast he completed his Empire State Building run-up. How many whole minutes is that? 9 whole minutes. And how many seconds?
55.
No.
5. Half. 30.
36.
30 seconds.
How are we going to determine how many seconds it is?
Oh, round it.
We're not going to round it.
It's 30 seconds.
60 times.
It's 30 or 40
Yeah.
seconds.
It's not 30 or 40. We got seconds in between 30 and 40. We want to be as precise as possible. How many seconds in a minute?
30.
60.
60.
Oh, I tweeted.
So I can take the decimal part, 0.55 seconds.
Wait, you said how many seconds in a minute?
How many seconds in a minute? How many seconds in a minute?
60.
60.
I tweeted.
So 60
We all make mistakes.
seconds and 1 minute.
Right.
Oh wait, I have 0.55 minutes, not seconds.
It's like 30.
Silly me. It's about 30 seconds. Is it exactly 30 seconds?
Nah.
There we go.
That's what I said.
You said 33. You said between 30 and 40.
Something.
I said 33, and then I said
All right.
Not said 30 to 40.
How do I multiply fractions together? Yep. First, I need a denominator so that this really is two fractions. What do I do if I notice the same unit on the top of one and on the bottom of another? They cancel out. Same units on the top of one and on the bottom of the other cancel each other out. Top to top, bottom to bottom. So what am I going to be multiplying together then? Yes, 0.55 is going to get multiplied to 60, and this will give me the number of seconds. When you multiply these two together, we get 33 seconds. So 9 minutes, 33 seconds. Was our other estimate of 9 minutes and 30 seconds pretty close?
Yeah.
Did we have a reasonably close estimate using our graph?
Yeah.
Yes. All right. We're going to switch gears at this point. All the examples yesterday, and even this example right here, we were finding solutions to equations, things with equal signs. I want to switch gears now and talk about inequalities. What's inequality mean?
Not equal.
Not equal. Things when we're talking about greater than, less than. Greater than or equal to would qualify. Less than or equal to. Most of my rules for inequalities, I'm on page 77 now. Most of my rules for inequalities are exactly the same as for when I'm solving an equation. If I add something to one side, I have to add it to the other side. If I subtract something from one side, I have to subtract it from the other. This will not change the direction of my inequality at all. You guys should have these examples in your book, page 77. If I start off with an inequality that I know is true, like 2 is greater than 0, is 2 actually greater than 0? Yeah, 2 really is bigger than 0. If I add 1 to both sides, I get 3 is greater than 1. Is that still true? 3 is bigger than 1. If I add something to both sides, my inequality stays exactly the same in between. What about if I subtract something from both sides? Will anything happen to my inequality?
Yeah, it's going to change.
Is it?
Yeah. If you subtracted 3 from, what you said, both sides?
Yep, from both sides. If I start off with an inequality that I know is true, 9 is bigger than 6. You guys agree that that's true? 9 really is bigger than 6? If I subtract 4 from both sides, I end up with 5 and 2. Is 5 bigger than 2?
Yeah.
My inequality stays exactly the same. If I add the same thing to both sides, if I subtract the same thing from both sides, my inequality sign will stay exactly the same. Multiplying and dividing is where we can run into some trouble. If I multiply or divide both sides of my inequality by a positive number, I've got an example of this right here. If I multiply or divide both sides by a positive number, you guys agree that 8 is bigger than negative 2?
Mm-hmm.
If I multiply both sides by 3, this side becomes 24, this side becomes negative 6. Is it still true that 24 is bigger than negative 6?
Yeah.
Yes, my inequality stayed exactly the same. Alligator is still eating the bigger thing, and I didn't have to switch it. If I multiply or divide by a negative, though, something happens here. Negative 4, less than negative 2. That is true. Less than means left on the number line. Do you guys agree that negative 4 is left of negative 2 on the number line?
Yeah.
So that first inequality is true. If I multiply both of these by negative 8, negative times a negative gives me a positive, so I have a positive 32. Over here, if I multiply by negative 8, I get a positive 16. I started off with a less than sign. Is 32 less than 16?
No.
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 32 is bigger than 16.
It is.
So the inequality that I started with, when I multiplied by a negative, it had to flip. Let's practice this with a couple inequalities. I want to solve this one, number 6 on page 78. Yay, decimals. All right. I'm always writing down my order of operations off to the side. I have PEMDAS. If we are solving, we are isolating. We're going backwards through the order of operations. We have to watch out for the multiplication and division step, though. Whether it's an equation or an inequality, if I'm solving, if I'm going backwards, I have to start with which operations?
Addition and subtraction.
Addition and subtraction. Look at the inequality that we have here.
Take his phone.
Negative 5.6n plus 12.9 is greater than or equal to negative 71.1. What's the first thing I would want to do up here as I'm trying to solve this?
Are we supposed to use somebody?
Are we supposed to what?
Subtract 12.9.
Subtract 12.9 from both sides. We start with any addition or subtraction. This is what I want to get alone, so I can't touch that. I need to get rid of the 12.9. All right, so I have negative 5.6n. Does anything happen to my inequality?
Yes.
By adding or subtracting things, will my inequality flip?
Subtract. Wait, no.
Nope. If I do it to both sides, my inequality stays the same. So this is going to stay greater than or equal to. What do I get when I combine these two together, though? Negative 71.1 minus 12.9. Negative 71.1 minus 12.9. I got negative 84. Can you guys double check? Yeah, okay, negative 84. Do we have n all by itself? Is n all alone yet? Have we solved? No. I still have that negative 5.6, right? We're going to divide. We have to flip the inequality, yes. Dividing by negative 5.6 on both sides. That's going to cancel here. But whenever we divide by a negative, my inequality is going to flip. So I have n greater than. Will this be a greater than? Less than or equal to. It's going to flip. Negative 84 divided by negative 5.6. 15. Why is it not negative 15? Negative divided by negative will turn to a positive. So here's my solution. I need to come down here and graph this. On the number line, what's the first thing I should put down? Where should I put my first mark on this number line? At 15. Where's 15 on the number line? In between 14 and 16. Okay. So, like this or like this? How do we decide? When it has the line underneath it, it is filled in. So less than or equal to, greater than or equal to, we have a filled in circle. If it's just a greater than or less than, this is when we do an open circle. Cool, am I done?
No.
No, you have to go there.
No, you You gotta,
I gotta shade it, right? Which way do I shade?
left.
How do you know?
Because it's facing this way, so all numbers are less.
Very specifically, what this inequality said is, I want to shade the values for n that would make this inequality true. So if I'm not sure which side I should shade on, I can substitute some of these numbers in here. Like if I take 6 and I put it in for n, is 6 less than n? Or sorry, less than 15? 6 is not less than 15?
I mean, yeah, I thought you said it was greater.
I can take these numbers here and substitute them in for n. If I would say, yes, that's true, then it should be shaded. What about if I grab a number on the other side, like 20? If I put 20 in here for n, is 20 less than or equal to 15? Then 20 should not be shaded. I need to shade this to the left. Every single number that is smaller than 15 would make this true. So how many solutions does this have? Does this have just one solution like we saw before?
No.
There's only one number that would make this true? No. When we shade on that number line, everything that we color in would make a true statement if I take it and substitute it in. We have an infinite number of solutions here. All right, let's look at one last problem to finish us off for today. Example number 7. We're on page 78 now. The recommended daily intake of calcium for teens is 1,300 milligrams. Jake gets 237 milligrams of calcium from a multivitamin he takes each morning, and 302 milligrams from each glass of skim milk that he drinks. How many glasses of milk would Jake need to drink to meet the recommendation? First thing we need to do here, we're going to write an inequality to represent this situation. If I'm writing an inequality, we have to define our variable. What we're going to use as a variable is the thing that we're looking for. What do we want to know in this problem? What are we trying to find? What did they ask us to find here? How many glasses of milk? That is what I'm going to use right here. We're going to use the letter G, and it equals the number of glasses of milk that Jake needs. I go look at my question. That's what my variable is going to mean. How many glasses of milk? My variable is how many glasses of milk. They have part of the inequality filled in for us. Where did they get this 302 number from? Where did that come from?
Milligrams for each glass.
Milligrams from each glass. That's why it has the G next to it here. 302 for every glass of milk. So if he has 2 glasses of milk, that's going to be 604. If he has another glass of milk, now we're at 906. The amount of calcium that he gets increases with each glass of milk that he drinks. So what do you think we're supposed to put on that line out in front? This right here. Why do they have a line with a plus sign? Where else is he getting calcium from? From his multivitamin. How much does he get from the multivitamin?
237 milligrams.
237 milligrams from the multivitamin. How many multivitamins does he take each day? How often do people normally take a multivitamin?
Like once.
Once a day. So he's just going to get 237 from the multivitamin because he only takes 1 pill each day.
Or, because sometimes you can take medicine, one in the morning, one in the nighttime.
True. Most of the time multivitamins are just a once a day, but they really should have clarified that in the problem.
Okay, she just clarified it.
Yep. All right, last thing we need to do is figure out which way this inequality needs to go. So talk to me about these numbers over here. The 237, 302 times G. Is that the recommendation? Or is that what Jake is consuming? This is what Jake is consuming, right?
Yeah.
So the 237 plus 302G is what Jake is consuming. What is this 1300 then? That's the recommendation, yes. You okay? Oh my, that didn't sound okay. Okay. All right, so there's our recommendation. When the government comes out with a recommended intake on something like calcium,
I'm sorry. I'm choking on him. I'm sorry. Oh,
Do you need a minute?
you make it here.
government comes out with a recommendation for calcium, and they say the recommended daily amount is 1,300. Do you think it's 1,300 or less? Or do you think they want us to consume 1,300 or more? So they want to make sure that we don't have too much of this, right? Because if it's that much or less, they don't want us to have too much of this. It's something that we should not have too much of in our diet. Do you think that's the truth with calcium here? No. With something like calcium, it's like, this is the minimum you should be having. You can have more than that, and that's fine, but you need to hit at least this mark. If they're talking about sodium intake or fat intake, then it would be looking at this much or less. But calcium, they usually want to make sure that we have at least that much. It's fine to go over that. So here's the recommended amount, 1,300. Should Jake be consuming less than that or more than that? More. So what inequality do I need right here then?
The greater than.
Greater than. Is it okay if he just stops right at 1,300? Yep. So I'm going to have an or equal to with this. Jake is supposed to consume at least this much or more. All right, let's go through and solve that. 237 plus 302G is greater than or equal to 1,300. Where do I start with solving this? It's the first thing I should do. Put your phone away for me, dear. Put your phone away, please.
Trent, put your phone away.
Put your phone away, please.
I think you should take
I heard subtract. What am I subtracting? Subtract 237 from both sides. So 302G is greater than or equal to 1,000. Yep, 1,063. So again, I'm using order of operations here. We always start down here if we are going to be solving or isolating. Since we're working with an inequality, do I need to worry about switching my inequality when I'm adding or subtracting? Nope. When I'm multiplying or dividing is when I have to watch out for this. Do we need to do any multiplying or dividing here?
Yes, dividing.
Dividing by what?
302 on both sides.
Divide both sides by 302. We're going to divide by 302 on both sides. Do I need to flip my inequality here? Why or why not? It's not a negative. Right here, if this is not negative, then there is no flip. All right, so I pop this in my calculator. G is greater than or equal to, round it out to 2 decimal places for me.
$3.51.
3.51, 3.52.
That's what I said, didn't I? I said that like.
You said 3.51, yeah.
No, like, not after her, before her, like way before her. It's on my calculator, look.
I believe you. 3.51, 3.52, depending on how you round that exactly. Yep, 3.519, so I would round that up. What does that answer mean? Shh. What does this answer mean?
That means you should take more.
He needs to drink how much milk each day?
More than wait, I don't know.
More than,
3.52 or equal to it.
yeah, he needs to drink like 3.5 cups of milk or more. Like 3.5, can you drink half a cup of milk? Yeah, so that decimal is okay. Jake needs to drink 3.52 glasses of milk or more each day. If our story problem had been about, I don't know, people instead of glasses of milk, and we got an answer like 3.5, can we have 0.5 of a person?
No.
No. If we're talking about people, if we're talking about animals, we're going to round to whole values. If I'm talking about glasses of milk or money or anything else where I can have parts of that and that's okay, then my decimal answers are all right. Does that make sense? All right. That is where we are stopping for today.
Miss Bo, let me tell you what she just said.
Hold on just one moment, and then I will come and listen.
No, we're going to say this out loud.
2.1 homework is due when?
Wednesday.
Which is? Tomorrow. Please make sure that you're turning this in on the McGraw-Hill site. Here are the book problems if you would like to work on it on paper first, but then you need to turn that in on the website.